Hello students, let's understand about surface chemistry, in which we'll be discussing about various phases. Now we have this vessel in which we have water and we have air over the surface of water. This surface is in contact with both the medias or phases. So this is known as interface. Now this is very important in this chapter because this is surface chemistry. So the branch of chemistry which deals with the study of phenomena occurring the surface or interface is called surface chemistry. So it depends on the nature of these two medias, how they are interacting, or these bulk phases. So let's understand what happens to this surface during this phenomena. One thing is for sure that when these two medias are in contact, they are immiscible. They are not going to mix together. That means they are forming this surface. Whereas in case of gases, there is no separation, though no formation of interface in case of gases, because the particles intermix very easily. So we can say they are miscible, so they are mixing with each other. Now these interfaces is normally few molecules thick. They are not very thicker. They are very small. They are very thin, and its area depends on the size of the particles of the bulk. Many important phenomena noticeable amongst these being phenomena such as corrosion, electrode processes, heterogeneous catalysis, dissolution and crystallization. They take place at these phases, this interface. It is very important, and the subject of surface chemistry finds many application in industry, analytical work and daily life situations. Now let's see what happens to the surface in a normal situation. Consider a vessel containing water. All the molecules of water are present here, and they are having same attractive force for their neighbors. That means they are exerting force on each other, towards each other. These weak forces are responsible for their attraction, and because of this they will be forming a force, overall force on each other, and the surface which is outer, which do not have any other similar molecule on its above, will be behaving like a stretched membrane, and this phenomena is known as surface tension. This occurs when these particles are behaving like a stretched membrane. Now these are weak forces. The substance is trying to behave like a stretched membrane, and it wants to decrease its surface area. Now when we are considering such molecules, they have slight attraction for some other type of particles also, and when these particles approach or reach these surfaces, they attach to them, and this phenomena of attaching these molecules on the surface of other material is known as adsorption. Okay, so Let's see what adsorption is. The term is adsorption. So it can be defined as the accumulation of molecular species at the surface rather than in the bulk of a solid or liquid is termed as adsorption. Now it means if we have a solid, consider this solid, and particles comes and attaches it to the surface itself, it is combining to the surface, they are coming and they are present at the surface only, they are not going inside the body. They are not going inside the body, that means they are not absorbed. This is adsorption. The other term which maybe you can confuse is absorption. It sounds same, absorption. In this process the particles can reach inside the other substance, other phase, and just like a sponge is dipped in water and it absorbs water, that is absorption. But in case of adsorption, the particle is limited on the surface only, and this is very important. We will be reading about catalysis, in which catalysts provide their surface for chemicals to react together and then they leave the surface. Now they are chemically changed, they are reacted, but the concentration of catalyst is not changing. So that is a phenomena associated with adsorption. Once again, adsorption, what is this? Is accumulation. That means the particles are accumulating, they are increasing in number around any surface. And then we have few terms. This is adsorbent, the substance on which the other material is attaching, and these particles are adsorbate. Adsorbate, the particles which are attaching. This is adsorbent, at which these particles are attaching. So this is a surface phenomena. Particles are just attaching to the surface. Adsorption is essentially a surface phenomena. Solids, particularly in finely divided liquid state, have a large surface area, and therefore charcoal, silica gel, alumina gel, these are certain examples at which adsorption takes place. And then we have reverse of adsorption, that is desorption. If particles are leaving, molecules are leaving any surface, adsorbate is leaving adsorbent, then this is desorption, opposite of adsorption. Adsorption can be easily seen in general situations, like if we have chalk, if we dissolve chalk, if we put chalk into water having ink. Consider this situation, water having ink, and then we put chalk into it, this cylindrical chalk. You will observe that if you break this this surface which is being put into this colored water, in that case you will observe that the surface, outer surface, will be having the color of ink, but inside the surface will be white. That means the ink or the liquid or this phase has not reached there, it is just absorbed at the surface. So this is adsorption, And adsorption and absorption can sometimes takes places together, and this is also known as sorption, in which absorption and adsorption takes place together. Simultaneously, it is occurring, takes place together. So this is what we know, sorption. As we know, these particles or the molecules which are forming any solid, they have their force of attraction between each other. Consider this to be a solid having these molecules, and they are exerting pressure, or attraction to each other, force of attraction amongst them. They are pulling each other with a force. Now the particle which is here is exerting force on its neighboring particles, and this is two-dimensional structure. In three-dimensional structure, there will also be one in the above position and below position of to this particle. Now it will be experiencing equal amount of force, but as we know, these surface molecules, they are at the ends or edges, they will be experiencing total inward force. They won't be experiencing force from the above, because there is no similar particle. So what they tend to do is they tend to attract other surrounding media particles. In case of any gases or liquid, they will be attracted towards them, though they are not same molecules, and because of this feeble attraction, they will attach to the surface. Now this attachment releases energy. There will be change in enthalpy in case particles are attaching to the surface. That means the reaction, there is a slight type of chemical change due to which they will release energy. Though actually it is not a chemical change, they are temporarily attached to the surface. This energy is released, this enthalpy will change, and in case of such type of adsorption processes, the heat is given out. So the enthalpy is negative in such processes. They are joining to the surface and energy is released, so they are attached until certain amount of energy is not provided once again to them. This is the case. And also there is change in entropy also. Consider these to be gas molecules. Now they were freely moving before attaching to the surface. Now after getting attached to this surface, their freedom is, it has changed. So the entropy has also changed. It should be negative in this case, because they are more disciplined. There is more order. Before they were disorder. So these are the conditions which should be kept in mind, that the value of enthalpy and entropy changes when these particles attach to the surface. And it happens so because they are now, whenever they are attaching to the surface, they are getting adsorbed, energy is released. That means they are exothermic. Whenever there is attachment, heat is released. This is exothermic change. And the entropy is also becoming negative. Is this process spontaneous? For a process to be spontaneous, the value of delta delta G should be negative, that means in this case, if delta G is negative, then this is spontaneous process. So we have delta G, Gibbs free energy, is equal to what the next value is, delta H, and then minus T delta S. Now we have seen enthalpy was negative and delta S, entropy, was also getting negative, and a process to become spontaneous, it should have delta G negative. Now delta G is going to become negative if this is negative, because these two negatives will add up and then the overall value summed to be negative. In that case, it means delta H is going to be negative. But if temperature is increased, this T is changing, so in that case what is going to happen? If delta H has sufficiently high negative value, T delta S will nullify. Overall delta G is negative. As the adsorption proceeds, as the adsorption is increasing, delta H will become less and less negative, because the surface is now not available for particles to attach, and that in that case these two values will become 0. Overall the value will become 0 and spontaneity will stop. Spontaneity will stop when delta H is going to increase. Why this is going to increase? Because before the solid or substance has surface, the particles are attaching and energy is being released. Now this surface is occupied by this layer of substance. Now the other particles which are coming will not be able to join to the surface. So in that case this value will have positive, enthalpy will turn to be positive. In that case the overall result of this equation would be 0 and spontaneity will not be there. Once the surface has been acquired, and at this state we can say there has been equilibrium attained by the system. So in that case delta G will be 0. Now in adsorption we have two different terms. One is physiosorption. Physiosorption. Now this occurs because of weak van der Waals forces. These are very weak in nature and just similar to gravitational force. As Earth has gravity now, because it has a large size, we can experience the gravity. The particles do have such type of force and we call it van der Waals force. Physiosorption, it is physical in nature and it depends on van der Waals forces. They are attracted to each other. It is weak in nature. And another one is chemisorption. It is because of chemical bonds. The particles gets attached to the surface and form chemical bonds like ionic or covalent bond, due to which they gets attached to the surface. And sometimes it may happen that these particles, when they are joined, for example hydrogen is like H2 gas is coming to the surface, it attaches to the surface, and these two atoms then separate out. They separate and react with some other substance and leave the surface. This is how catalysis takes place. So chemosorption in this case, and physisorption in generally particles when get attached to the surface due to weak van der Waals forces.